Our lecture today is about the formation of muscle impulse or muscle action potential. Objectives. First of all, we are going to explain what we mean by muscle action potential, the muscle impulse, and the sliding filament theory of the contraction. List the events that occur during cross-bridges cycles and describe the role of adenosine triphosphate in muscle contraction. Electrical properties of skeletal muscle. Skeletal muscle is an excitable tissue. When it is stimulated, it causes action potential. We call it the muscle impulse. The differences of action potential of skeletal muscle from that of nerve action potential. First of all, we have the resting memory potential of skeletal muscle is minus 90 millivolt. The firing level is minus 60 millivolt. Duration of muscle impulse is about 2 to 4 milliseconds, and it will not pass in after hyperpolarization period even in repeated stimuli. يعني skeletal muscle never pass in ما يسمى بالaccommodation of the accommodation or adaptation. And when we apply a repeated constant stimulus, there will be continuous contraction of skeletal muscle, contraction and relaxation without accommodation. The potential of muscle can be recorded during the contraction, and this record we call it electromyography, and it records the algebraic summation of action potential of skeletal muscle fiber, of all skeletal muscle fibers. The contractile property of skeletal muscle. When the muscle is stimulated, it contracts, and after the contraction and contraction and when there is no stimulus, it will go to relax. The contraction is done by the shortening in the length but return to its original length in relaxation. Muscle cannot contract without stimulus. This is called the excitation contraction coupling. We mean there is no contraction without excitation of the muscle, and when there is excitation should be followed by contraction. The muscle going to convert the electrical energy to mechanical energy. The sliding filament theory of the muscle contraction suggested that the head of myosin cross bridges can attach to an actin binding site and bend slightly, pulling the actin myofilaments with it. When the head can release and combine with another binding site, and this is going to make further bending of the actin myofilaments. Cross bridges of myofilaments contain the enzyme adenosine triphosphatase, which catalyze the breakdown of adenosine triphosphate to adenosine diphosphate and phosphate and energy that provides the force with which the cross bridges pulse, and the cycle can repeated over and over. This is a picture again show us the structure of the skeletal muscle fiber. Now, major events of skeletal muscle contraction and relaxation. First of all, the distal end of the somatic motor neuron release neurotransmitter اللي هو الستالكولين. الستالكولين diffuse across the gap اللي نسميها بالsynaptic cleft at the neuromuscular junction. The sarcolemma is stimulated and the muscle impulses travels over the surface of the muscle fiber and pass deep into the fiber through ما يسمى بالT tubules أو transverse tubules and reach to the sarcoplasmic reticulum. Calcium ion diffuse from the sarcoplasmic reticulum into the sarcoplasm and bind to troponin C protein molecules. This is going to make the tropomyosin molecules, tropomyosin troponin complex, we're going to move and expose the specific sites or the binding sites of the actin myofilaments. The actin and myosin myofilaments forming a linkage, and actin myofilaments are pulled inward by myosin cross bridges and the muscle fiber shortens as a contraction and as the contractions occur. Now, the muscle fiber relaxation after the end of the stimulus, the acetylcholine أو choline esterase enzyme going to أو this is طبعا الكولين acetylcholine esterase or choline esterase enzyme presented at the neuromuscular junction on the membrane of the motor end plate, going to destroy the free acetylcholine, and the muscle fiber membrane is no longer stimulated. Calcium ions are actively transported again to the sarcoplasmic reticulum. The linkage between the actin and myosin myofilaments going to break. The troponin and tropomyosin complex molecules going to or turn back to cover the binding site of actin myofilaments. Actin and myosin myofilaments slide apart and muscle fiber relax, and it at a resting state it return to its original length. When a muscle fiber is at rest, tropomyosin troponin complex block the binding site on the actin molecules and thus prevent the formation of linkage and prevent the interaction between the actin and myosin. Both contraction and relaxation are an active process and need energy. We mean by fatigue of the skeletal muscle is due to adenosine triphosphate source is lost in the muscle, and with continuous contraction the adenosine triphosphate going to be lost or going to be reduced, and the muscle need more energy. There is a depletion of muscle glycogen due to the interruption of the blood flow through the muscle contraction and loss of nutrient supply, especially loss of oxygen. Therefore, the muscle stop contraction. Muscle hypertrophy take place after forceful muscular activity. This is cause the muscle size going to be increased because of the increase in the diameter of the muscle fiber and increase the number of the muscle fiber, lead to ما يسمى بالmuscle hyperatrophy. While the muscle atrophy resulted from the non-using muscle for a long period of time, and this resulted from the muscle denervation. Now, summary to our lecture: skeletal muscle is an excitable tissue, and when it's stimulated it will cause action potential. We call it muscle impulse. The muscle cannot contract without stimulus. We call it excitation contraction coupling. The sliding filament theory of the muscle contraction suggested that the head of myosin cross bridges can attach, occupy the binding site of actin, and bend slightly, pulling the actin filaments with it. Within the head can release and attach to another binding site. Both contraction and relaxation of skeletal muscle are an active process and need energy. This is a few questions about the skeletal muscle fiber contraction, and thank you.